countdown.
Congratulations! This live broadcast is specially brought to you by Academy YouTuber Malaysia, an initiative by eDidik Malaysia and Kelab Guru Malaysia. Please pay attention. The live broadcast will begin shortly. The link to the certificate of attendance will be provided at the end of the session. Please make sure it is filled within the stipulated time. Thank you.
Good evening, teachers, parents, and all the wonderful students. Welcome to Pusat Tuisyen Academy YouTuber. Bermula percuma, selamanya percuma. How are you doing today? I hope all of you are ready for today's lesson. Before we proceed, let's begin our session by reciting a prayer for Muslims. The non-Muslims may pray according to your own religions. Okay, let me introduce myself. I'm teacher Lau from SMK Tinggi Klang, the moderator of the day. We at Pusat Tuisyen Academy YouTuber will provide you with free online classes. Let's take this opportunity to do your revision. So are you ready? Let me introduce our teacher for today's lesson. We have teacher Cikgu Shahnon from College Matrikulasi Pulau Pinang as our presenter today. We are now live on teacher Cikgu Shahnon's channel. Please support his channel by clicking subscribe now. The topic of today's lesson is atoms and molecules, or atoms and molecules. And together with us, we also have teacher Kong from College Matrikulasi Perak as a control host today. She in charge to ensure the smoothness of our lesson on technical support. And we also have teacher Tang from College Matrikulasi Selangor as an observer to ensure the smoothness of our lessons. So before we begin, I have a few reminders to all of you. First, please pay attention to our lesson. Stop chatting and use the chat session wisely. Number two, regarding the certificate link, the link will be given at the end of our session. Please use eDidik account when you fill in your particulars, and make sure to listen to the passcode given by me or the presenter by the end of the lesson, and fill in the form within the time limit, which is 30 minutes. So without further ado, before we start the lesson, I want to give you the passcode. The first passcode, that is A2, okay, A2. Okay, so without further ado, let's welcome Cikgu Shahnon.
Okay, Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. How are you, everybody? I hope all of you are fine. So this is my poster, all right? My poster. And then this is my profile. My name is Shahnon bin Awi from College Matrikulasi Pulau Pinang. Teaching experience about 21 years, and my channel is www.youtube.com/Shahnon channel. All right. And this is our team, Kimia Prayu. We have teacher Vivi Lau as a moderator today, teacher Tang as an observer, me, Cikgu Mawar, and teacher Kong as a host controller. And then we have a mathematics team led by teacher Im, biology Prayu led by Cikgu Faiza, per-accountant and economy led by Madam Fizi, and the last one is physics led by Madam Rosmaya. All right, and this is Academy YouTuber Malaysia portal. You can get more information from this portal. All right, from www.academyyoutuber.com. Many information you can get from here. Okay, our topic today is atoms and molecule, and our objective: describe the structure of an atom, define proton number and nucleon number, write the notation for nuclides, compute the number of protons, electron, and neutron in atoms and ion, and define and distinguish the isotopes of an element. Okay. Okay. We look at model of an atom. Model of an atom. Uh, we have atomic nucleus. Okay. Atomic nucleus here we have we also call it as a nucleon, and it consists of proton, okay, proton, P, and it has a positive charge, and neutron, okay, neutron is neutral, and then move around the atomic nucleus is electron, okay, the symbol is E, and it has a negative charge. Okay, so from model of an atom, we know that the three particles that are fundamental to the composition of atom are the proton, the neutron, and electron. All right, and then straight we go to the nuclide symbol. Alternative name for nuclide symbol is isotopic notation or atomic symbol. Okay. First, we have to write the symbol of element. Okay, symbol of element X, for example. Symbol of element, for example, hydrogen is capital H, oxygen is capital O, right? So X is represent the element in periodic table, and then we have a subscript um, on our left hand side. Okay, Z is proton number or atomic number, proton number or atomic number. And then we have a here, superscript on our left hand side, nucleon number, okay, or mass number or nucleon number. And A, the nucleon number equal to Z, proton number plus neutron number, okay. And then we also have on our right hand side, C plus minus here. Okay, plus minus is a charge on an ion. Okay. Okay. So if the number of electron equal to the number of proton, the number of electron equal to the number of proton, there is a neutral atom. Okay. If the number of electron more than number of proton, then it's become an ion. Okay, negative charge. It's become negative. If the number of electron less than number of proton, it's become cation. So this is a nuclear symbol. Okay, you have to know to write the nuclear symbol X, A, Z, and its charge. Okay, example. For example, we have aluminium here. For example, aluminium is an element, and this element has 13 proton, and the nucleon number is 27. And here we have 3 plus here. 3 plus here is a charge of aluminium. Okay, and the second example is oxygen. Oxygen has 8 proton, 16 nucleon number, and this is the charge of oxygen 2 minus. Remember that we have to write correctly the charge of element 2 and then minus or positive. If we write negative and 2, that's the wrong way. The wrong way to write the isotopic notation. Okay, it must start from number number, and then the charge, whether negative or positive. Okay, we look at example. We have a copper here, Cu2 plus, Cu2 plus, and then 29 and 63. And then we have a blank here, is the proton number. So from this information, we know that 29 is the proton number of copper. Okay, it is the total number of proton in an atomic nucleus of copper. Okay. Okay, and then number 2, 63. What is 63? 63 is the nucleon number of the nuclide of copper. Okay, and nucleon number is defined as the total number of protons and neutron in an atomic nucleus. Okay, all right. Okay, this is exercise. We have three nuclide. We have krypton, Kr, cobalt, Co, and oxygen, O. Okay. The first question is, I can see that we have a 54 observer now. Okay. So the nuclear number of krypton. What is the answer for the nuclear number of krypton? So anybody want to answer? You can use your chat box. The nucleon number of krypton. Okay. Okay, student. Very easy. This is very easy. The nucleon number of Kr, krypton. Very easy. Just look at the krypton and find the nucleon number. What is the answer? Okay, students, let's try. Okay, good. Okay.
Syamimi 84, Alia
84,
16.
Al-Hafiz. Okay, good. I can see a lot of them.
Yeah, many answers.
Okay, the answer is 84. Good. And then the second is the proton number of cobalt ion, CO3 plus. I think this is also a very easy question. Very easy question. The proton number of cobalt ion, CO3 plus. What is the answer? What is the answer? CO3 plus,
From Syamimi
27.
27.
Good, Shamimi. Al-Hafiz. Okay, good.
Masya Hafiz.
All right. Okay, 27. And then the third one, the number of neutron in Kr, krypton, this one, is neutron. Okay, this one you have to use calculator. This one you have to use calculator. What is the neutron number of krypton? Use your calculator. 84 minus 36.
From Syamimi
48.
48.
Okay, good. Okay, 48. Okay, the fourth one. Contains 10 electron. Wow. Which ones contain 10 electron? 10 electron. Okay, student. Blank, and then contains 10 electron. What's the answer? What should be the answer?
From Alia, oxygen.
Oxygen. Is it oxygen? Or you should be more specific. I think it
From Jing
should be more
E,
specific.
oxygen ion.
Yeah, because if oxygen, it could be oxygen atom, right? If oxygen atom, it's not contain 10 electron. So it should be oxygen ion, or the best answer is O2 minus. Okay, O2 minus. Because we know that the proton number of oxygen is 8. That's mean if the oxygen is neutral, it also has 8 electron. And then we look at the charge here, 2 minus. That means this oxygen accept 2 more electrons, so it's become 10 electron, right? All right, and then the last one, CO3 plus. CO3 plus consists of blank proton, blank electron, and blank neutron. CO3 plus. We have to refer to the CO3 plus. First, proton. Okay, proton. We already know that 27. All right, 27. Electron. We have to refer to the charge of cobalt here. So 3 plus. That means the number of electron must be less than number of proton. Okay, because the charge is positive. Okay, the charge is positive means the number of electron must be less than number of proton. So the answer is of course 24. 24. 27 minus 3. Okay, good, Alia Najwa, 24. And the neutron. The neutron, 59 minus 27. Okay, the answer is 32. Okay, good, Shamimi Auni. Okay, good. Okay, this exercise, I think, quite easy. Okay, if we have this kind of question, we are given table like this, and the question is complete the following table, and we are given species. The species is bukan nama sebenar lah, MQFT. We don't know whether this is aluminium or oxygen or whatever. MQFT is bukan nama sebenar, bukan nama sebenar. MQFT. And then we are given this information: Z, A, number of N, number of P, number of E, and then charge on the species. Okay, this is the question. And we have a blank here, blank area here. We have to fill with the answer. Okay, the Z is 24. We know that the Z is proton number. All right, the Z is proton number. A is nucleon number, and blank here. And then we have a number of N. N is neutron, right? A neutron. So what would be the A nucleon number? Okay. Okay, student, what would be the A? A should be, I give the clue. The clue is very simple. Z plus number of neutron. You have to use your calculator, scientific calculator. You have to use your scientific calculator. If you use the normal calculator, then you cannot answer the question.
There's an answer.
Okay, the answer is
The answer
52.
from
Okay,
Malaysia,
okay, good.
52.
24 plus 28. Huh? You have to use scientific calculator.
Yeah.
All right. And then we have here is number of P. P is the proton number. Okay, proton number. Of course, we just refer to the Z, right? We refer to Z, the answer is 24. And then we have number of electron. Okay, remember that number of electron, we have to refer to the charge on the species, 3 plus here. Okay, 3 plus. That's mean number of electron positive. If the charge is positive, that's mean the number of electron must be less than number of proton. Okay, so the number of electron should be 24 minus 3. 21. Good. Islin Irisha. Okay, good. 21. Okay, this is how we fill in the blank if we have this kind of question. Okay, we go to the Q. Q, okay. The Z is not given. Okay, we have a dash here. Dash here means not given. Okay, we are not given the proton number. How we want to calculate the A? Okay, and then this is a blank area. Number of neutron. Okay, we have a number of neutron, but we have the proton number. As we know that the number of proton equal to the Z, the proton number. Okay, we have a two terms here, proton number and number of proton. Okay, can you see the difference? More or less the same, right? This is a proton number. and the proton number of the element equal to the number of proton of that element. Okay, so that's mean the Z here is equal to 13, right? So of course the A is 14 plus 13. All right, so we can calculate the A. The proton number, the nucleon number. The nucleon number is 14 plus 13. Okay. And then the number of electron we look at here, the charge on the species is 0. That's mean no charge. That's mean the number of electron equal to the number of proton, 13. Okay, 13. All right. Okay, we go to the F. F, we have a Z, the proton number. We have a nucleon number, 19. And we have to determine the number of neutron. And we are not given the proton number. Kan? We are not given the proton number. Okay, so the neutron number, easy for us to calculate. 19 minus 9. The answer is 10. Okay, that's 10. Okay, we are not given the proton number. We don't know the number of proton, but we have the number of electron. What would be the charge on the species? Okay, what would be the charge of the species? Okay, so the number of electron is 10. We don't know the number of proton, but we can refer to the Z. Okay, we can refer to the Z. 9, that's mean we have excess of electron, means the charge must be negative. Okay, 10 minus 9, -9, okay, -1. But in to write the charge on the species, we cannot write -1. Cannot. Okay, we just write the negative, something like this. This is the symbol of negative, right? We just use negative like this. If you write negative and 1, cannot. Or you write the 1 and then negative. You write 1 and negative. That's the wrong way how to write the nuclide symbol of element. Okay, so we just use negative for 1. Okay, all right. And the last one is T. We are not given the Z and the A. Okay, dash here. We know the neutron number, we know the proton number, and we know the number of electron. So the charge, the electron is more than proton. So this one should be 2 minus, right? 2 minus. And the correct way how to write the charge is number first and then the sign, whether it is positive or negative. Okay. If the charge is 1, we just write the sign, negative or positive. Okay. Okay, the last one is write the notation, atomic symbol for nuclide T. Okay, this is T. This is T. Okay, that's mean we have to write the symbol of T. In this case, T. Okay, we just write T. And then we want to write the proton number. Refer to the Z here. Okay, no number here, but we can refer to the proton number 8. Okay, we know that the Z is 8. And then we want to write the A nucleon number, also not given in this table, but we can write it, we can calculate it, number of neutron plus proton, 18, and the charge is 2 minus. So the answer is T, and then we have 18, and then the 8, and 2 minus. Okay. I think, okay, we go to the isotopes. We go to the isotopes. Now it's 24. Okay. This is very, very important. After we know how to write the nuclide symbol, and then we know that what is a definition of isotope? Isotope are 2 or more atoms of the same element that have the same number of protons in their nuclei but differ in the number of neutrons. All right. For example, Here we have a hydrogen atom. The symbol is H, capital H. Okay, we already know from Form 4, Form 5, we already know that the symbol of hydrogen is capital H. Okay, and the proton number of hydrogen is 1. Okay, the proton number of hydrogen is 1. Okay, so Z. Okay, so H111. All right, but ding, 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 look at the A, nucleon number. Okay, the nucleon number, the first one is 1. The second one of hydrogen is 2, and the third one is H. So these three hydrogen, we call it isotopes. Okay, because they have the same proton number but differ in nucleon number or neutron number. Okay, right. In this case, the number of neutron for protium, okay, it has a special name for this one: protium, deuterium, tritium. Okay, it has a special name, but usually we just know that this species, we call it hydrogen, right? Because it has a one proton, so we call it proton. Okay, so this is isotope. This is isotope. Actually, in periodic table, we have a relative atomic mass and so on. We can see that there is a relative. Relative means relative mean here because average from a lot of isotope of element. Okay, we will go after this. Okay, if this hydrogen atom lost its electron, we call it hydrogen ion or proton. Sometimes we call it proton or hydrogen ion. If this hydrogen lost its electron. Okay, if this hydrogen accept one electron, we call it as a hydride ion. Hydride ion, right? Remember? Hydrogen ion or proton, sometimes we call it proton, not proton saga. This is a hydrogen. Okay, if you heard that a proton, that's not the Vira, not the saga, and so on. This is hydrogen ion. Okay. Okay. This one. This is exercise. Given the nuclide, we have a T 13.6, R 14.6, and Z 15.7. The question is write the nuclide that are isotopes. Which one is isotope? Okay. Okay, student, can you answer? Write the nuclides that are isotope. Whether it is TNR or TNZ or RNZ. TNR, okay, Li Hai Jin, TNR, good. Jin Chai, TNR, okay, good. Okay, good. That's mean you understand that the meaning of isotope, the number of proton must be the same. Okay, the number of proton must be the same. So the TNR are isotopes. Okay, second question. State the atom that have the same number of neutron. Okay, state the atom that have the same number of neutron. In this case, we have to do some calculation. Okay, because the neutron we have to minus the A and Z and so on. So we have to do some calculation. Which of these three species here are that have same number of neutron? Okay. R and Z. R and Z. Okay. Shamimi Auni. Okay, good. R and Z. And then Jin Chai. R and Z. Good, good. Okay. Good. Fairis Kuzaimi. Okay, good. Okay. This one also easy to calculate. You can use your scientific calculator. Okay. Scientific calculator. The A minus Z. And then the answer is R and Z. 14 minus 6 equal to 15 minus 7. Okay. So atom is the atom that have the same number of neutron. Okay.
Sorry,
Okay. This is okay. Okay. This is
Cikgu
summary.
Shahnon,
Okay. I will
summary
end with
first.
the summary. After this, we will go to the next level, which is spectrometer, mass spectrometer. Okay. The summary: fundamental particle in atom proton. We have proton, a neutron, an electron, and the atomic symbol. You have to remember how to write the atomic symbol. We have an egg, we have an AZ, and charge, and the nucleon number equal to proton number plus neutron number. And the last one is isotope, atom of the same element that have the same proton number but different nucleon number. Okay, I give
Okay.
this to the our moderator.
Thank you. Thank you, Cikgu Shahnon. So we are going to rest for a while and for the advertisement. Before that, I want to give you the second passcode, which is 06. Okay. Let's
Wow,
go for
banyaknya
the...
hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang. Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.
Okay, Cikgu Shahnon, you can continue.
Okay, welcome back. Okay, for our next session is a mass spectrometer. Our objective to define relative atomic mass and relative molecular mass based on the carbon-12 scale, and then interpret and analyze the mass spectra. All right. Actually, in atom and molecule, we have a micro world, okay, very tiny. And in our real life, we call it macro world. Okay, we weight whatever in gram, for example. But how we want to weight the atom here using our our ordinary balance. How we want to weight atom here using this ordinary balance? Cannot, right? Okay, so it is impossible to weight accurately an atom or molecule. So we will use a relative scale. Relative scale. Since carbon-12 is one of the most stable and abundant atom or isotope in Earth, scientists decided to use it as a main standard of comparison. Okay, that's why we always heard that carbon-12, and so on, because of this. And mass of all atoms, molecule, ion are measured in relative to the mass of 1/12, the mass of carbon-12 atom. Okay. So we have a definition of relative atomic mass. I believe that in Form 4, Form 5, you already know this one, relative atomic mass, AR. We use symbol of AR, relative atomic mass, average mass of one atom of the element divided by 1/12 times mass of one atom carbon-12. And for relative molecular mass, sometimes we have a combination of atom of a different element and so on. So how to write the relative molecular mass? The same things. Average mass of one molecule of the substance divided by 1/12 times mass of one atom of carbon-12. Okay, and the symbol is AR. AR stand for relative atomic mass. A stand for atomic mass. MR stand for relative molecular mass. And and no unit. For relative atomic mass, there is no unit. Relative molecular mass, there is no unit. Okay, because we have a ratio here, ratio of elements and ratio of carbon. So no unit. Okay, this is a max spectrometer. This is how isotope are detected. Okay, first, this is our sample. You can see here. The sample will put in the vaporization chamber. So the sample will be it will vaporize. The sample will become gas. Okay, and then after that you will enter what we call ionization chamber. In this chamber, we have a heater here, heated filament. It will bombard our sample, and it will produce ion from the sample. The ion is positive. Okay, the positive charge. Okay, as you can see here. And then after ionization chamber, you'll go to the aceleration chamber. The positive ion here will be accelerate, accelerate, and go to the magnetic chamber. In this magnetic chamber, it will separate ion according to their mass to charge ratio. Okay. For example, here we have oxygen, for example, and we know that oxygen has many isotope. Let's say 3. Okay. Let's say 3. We have let's say 3. So from here, at this magnetic chamber, this mass spectrometer will separate the isotope of oxygen according to their mass to charge ratio. Okay, and we have an amplifier here, and then it will detect the ion, and it will record as what we call mass spectrum. Okay, okay. This machine, we call it mass spectrometer, and as a chemist, you have to know how to analyze this one, uh, the mass spectrum. Okay, now we go to the mass spectrum. All right. For example, this is mass spectrum of rubidium. Okay, we have an element named rubidium. Okay, rubidium. We have a relative abundance here, and okay, the interpretation and point to remember. What does it mean? The peak of this mass spectrum. Okay, one peak correspond to one species. We have 2 peak here. This one peak, and this one. Okay, I think I want to change this to highlighter first. Okay, okay, we have 2 peak here. Say interpretation, we have 2 peak of rubidium 85. This is rubidium 85 and rubidium 87. That means rubidium has 2 isotopes. Okay, 2 isotopes. All right, and then oh, I don't want this one. I want to change to okay, pointation. So okay. Okay. Wait a minute. Arrow. I just zoom. How to change it? Automatic link highlighter. All right. The height of peak, we have height of peak means the amount, relative percentage abundance of the respective species. For example, here we have rubidium 85. The height is go to the 18 here. The height of each line. Rubidium 85, the relative abundance means the amount, how many, okay, how many, 18, 18. And for rubidium 87, 7, okay, this is amount of rubidium 87. In this case, relative. It could be in ratio. Okay, it could be in percentage and so on. But this one is in ratio. I believe that this is in ratio because there are different between ratio and percentage. In ratio, if we 18 plus 7 is not equal to 100. That means that is in ratio. If we total up these two, it's become 100. That means the relative in percentage. Okay. So this is what you have to know. Okay. You have to know that in this case, if you look at this mass spectrum of rubidium, we know that rubidium has two isotopes, isotope 85, isotope 87. M over E here is mass over charge. Okay, mass here refer to the A. Mass here refer to the A, nucleon number, right? The nucleon number. Okay, E is charge because in mass spectrometer, it's become a positive charge. Okay, it's become ion, and then it can be detected by the ion detector. Okay. Okay, from this we know that it has two isotope, and the peaks of rubidium means the abundance, the relative abundance. We know that rubidium 87 more abundance than rubidium 87 from this what we call it graph, from this graph, from the graph we know from this. Okay, x-axis is isotopic mass. Okay, yes, as I said, isotopic mass or nucleon number. X-axis m over e, charge, mass over charge. Okay, if we know this, then we can do some calculation and so on. Okay, this is the same rubidium. This is the same rubidium. We have a relative abundance, and then we have isotopes of rubidium. The question is, write the notation for rubidium isotope. Okay, write the notation. Easy to write this one because we already know that it has two isotopes. We just write Rb. Rb is a symbol for rubidium. And then 85 is a nucleon number. So 85. We put it here. 85, something like that. Okay. And what is the proton number? Okay. From this graph, actually we don't know the proton number. So no need for us to write the proton number. If we want to check the proton number, we have to check from reference. We have to check from reference, for example, from periodic table, and we will know the proton number of rubidium. But from this question, we just know the nucleon number of rubidium from this question 85 here. Okay, and then we have a rubidium 87. Okay, rubidium 87 from this question, rubidium 87. This is isotopes of rubidium. We have rubidium 85, rubidium 87. Okay, is it clear? If clear, you can write on the chat box. If you're not clear, maybe I can give some explanation to make it clear. Okay, you can write. Okay. And then the second question, calculate the average atomic mass of rubidium. This is the second question. Clear, good. Jingy, okay, clear. Crystal clear. All right. Calculate the average atomic mass of rubidium. How to calculate the average? All right. We have two isotopes with different relative abundance, with different relative abundance. So in this case, we have to use the formula. The formula is very easy. The formula is this one. Average, we call it average atomic mass. Okay, average atomic mass, sum of Mi times Qi divided by sum Qi. Okay, M means for mass. Okay, MI. Okay, M stand for mass kan. Jadi 85. This is mass of rubidium 85. Q stand for quantity. Okay, quantity. This one is quantity. This one is relative abundance. It could be in percentage. It could be in ratio. Okay. Okay. Quantity. Say so 85 times its abundance, and then we have 2. So plus, because this is sum. This is mathematic. This is mathematic. 87 times 7. All right. Divided by sum of QI. QI is relative abundance. We total up the abundance of the isotope, and then use your calculator, and then you will get the answer. Okay. So 85 times 18, okay, plus 87 times 7 divided by 18 plus 7. Okay. And the answer is 85.56, and it has a unit. U. We will use U, or also we can use AMU. 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 Atomic mass unit. AMU or U. Okay. Because this is average. Average atomic mass. Different with relative atomic mass. If we have a relative atomic mass, yes, no unit. But this one is average atomic mass. That means it has a unit. Okay. Okay. Average atomic mass 85.56. All right. Okay. The third question, or C, what is the percentage abundance of each of the isotopes? Isotope 85, the abundance is 18. Now we have to change it to percentage. This is simple mathematics actually. Simple mathematics. You have learned it in Darjah 5, Darjah 6. Okay. Okay, the solution is 18 divided by 18 plus 7. Okay. We total up the abundance and times 100%. The answer is 72%. Okay, the answer is 72%. That means the relative abundance is 18 compared to the relative abundance of 87 is 7. But if we convert to the percentage, it's become 72. And then percentage abundance of rubidium 87 is 28. We can use two ways. Number one is 7 divided by 25 times 100%, or 100 minus 72. Okay, 100 minus 72, you will get 28%. Yeah? 28% of rubidium 87. All right. All right. The best thing about this mass spectrum of rubidium is the average is 85.56, right? 85.56. Okay, this one you have to remember very carefully. The average atomic mass of rubidium must be in between 85 to 87, because the average must be in 85 to 87. Sometimes we maybe we confuse, or our calculator not function well, and then when we calculate, it's become not 85. Maybe it's become 90, for example. Okay, if you understand this, you know that this is wrong, because the average must be between 85 to 87. If your calculation becomes 90, that means something wrong. Or your calculation become 50, for example, 50, not in the range between 85 to 87. That means something wrong with your calculation. Okay, maybe when you add your whatever here, okay, something here lah. I don't know, maybe something here. Okay, the second thing is, look at here, 85.56, near to the 85. Why? Because the percentage of rubidium is 72. That means Rubella rectified is um, we have a lot of the amount of Rubella rectified is larger than amount of Rubella 87. So the average must be near to the 85. Okay, 85.56, right? If your calculation becomes near to the 87, for example, 86, okay, maybe something wrong there, because look at the percentage here. Look at the percentage, 28. This one is 72. Okay, can you get the idea? Okay, wow, 15 now. Okay, I have to. All right, all right. And then, okay, this is how we calculate the relative atomic mass. Okay, relative atomic mass, we just add now with 85.56 U. Okay, this is from average, and then we divide it by 1 over 12 time 12.UU. This is a mass of carbon 12. So now the value is the same, 85.56, but no unit. For relative of rubidium, for relative atomic mass of rubidium, without unit, 85.56, because actually we divided with 1 over 12 carbon 12. The unit is U, so we can cancel the U because of that. The value of AR of rubidium without unit, 85.56. Okay, the last one. Okay, this is the last one. Okay, determine the average atomic mass of magnesium. Okay, we have a magnesium here. Magnesium, huh? We have 3 isotopes of magnesium: magnesium 24, 25, and 26. And this is the relative abundance of magnesium, 63, 9.1, and 8.1. So you can do your calculation. Okay, I just give you the formula. This is the formula. Okay. What is the average atomic mass? Average, huh? Average mean no need for us to um, go to the next step with carbon 12. Okay, so then try to answer this question. Average atomic mass. Remember that when you calculate it, make sure that the answer must be in between 24 to 26. Okay, in between 24 to 26. If more than that or less than that, that means you're out of range, means um, something wrong with your calculation, something wrong with your calculator, something wrong with your formula, or whatever. Okay. What's the answer? Still waiting for the answer. In this case, we have 3 isotopes.
Okay, so there's answer
24.33.
semi-me
Okay.
24.32 U.
24.33. Okay. Xiaomi 24.3 unit. This one average. Average mean with unit. With unit. Kismina. Average must be in. There is a unit U. We will put U or AMU. Atomic mass unit. AMU or U. Average. Okay, Marisha, 24.33. Good. Okay, good. All right. Good. Okay, this is how to calculate 24 times 63, and then 25 times 8.81, 26 times 91, and then sum of QI, quantity, QI 63 plus 8.1 and 9.1. And the answer is 24.3. Good. Congratulations. Congratulations. That means today is I can deliver it very well, I think. Okay? Many of you can understand it good. So thank you very much for participating with us today, and don't forget to subscribe, like, and share, and don't forget next week we will have our live session. Okay, our live session. I think with teacher Kong, teacher Kong. Okay, teacher Kong. Okay, will be your next presenter. So go back to our moderator.
Okay. Thank you, Cikgu Shahnon. With God's grace, we are done with today's session. We have learned a lot from Cikgu Shahnon about atoms and molecules. Congratulations to those who are able to follow our sessions from the beginning till the end. And thank you very much, Cikgu Shahnon, for such an interesting lesson. Before I provide the certificate link, please check the checkbox for the certificate link. Please off the live chat button and click subscribe button if you haven't. This is to show your appreciation to Cikgu Shahnon for giving you a free lesson today. Don't forget to click the bell button too, so you won't miss out any new videos and live lessons from Cikgu Shahnon. If you like today's class, then please click like and share it to your social media friends. Let's share the knowledge you received today with them. Sharing is caring, right? When you finish, type done in the chat section. Then I will give you the certificate link. Once again, I would like to thank you, Cikgu Shahnon, for the interesting lesson. Thank you also to Teacher Kong and Teacher Tang for being with us today. I think that's all for now. See you in another session. Please do remember, stay at home. Goodbye, everyone. Have a nice weekend.
Bye-bye.
Tuisyen online percuma. Tuisyen online percuma. Layari www.academyyoutuber bagi mengikuti tuisyen online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Akademi YouTuber. Rujuk jadual di laman sesawang www.academyyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuisyen online percuma, mestilah Akademi YouTuber.